So we corrected a few of the issues. In looking at this, I'm not sure why we have a longer slot. It's not like this is going to be able to move. Maybe it's a quick adjustment to get it aligned, and then whatever this attaches to, make the be able to move it back and forth with a larger range, and then be able to fit it within these. Though I still don't know that I would make that particular groove that much bigger. So 60 millimeters versus 20 millimeters. If I was really, I'd like to have the three contact points to put either a button head, a socket head, or a hex into. I would think that if I made that 30 and that 30 and that guy 30, I'd be a lot happier with the overall kind of build on that. So um, I'll hold off and revisit that one later. So as far as pins, we said that the lip will act as part of that, but we also, if we go to make this a pinned item, then we'd want to follow one of the manufacturing processes recommendations that I'm going to go ahead and put in for the location. And typically I'd want as much movement as I can stand in this larger piece. So looking at it from an assembly standpoint, I'm going to slide this piece into this piece. That's pure conjecture as far as how I'm visualizing it. So if we go to, let's see, let's go ahead and reset the custom sizing. If I had was going to use that particular counterbore, I would set it as a favorite and save it into my system. So this being a dowel pin hole, we set for the M6. I'm going to go ahead and use a 6 millimeter, about 1/4 of an inch dowel pin. The process then we'll do for our feature scope is just the first block, and the diameter is 6 millimeters. So if we were to say even ream these on the tall side, and we'd probably want to limit it. So that being the case, I'm starting to think about those fits, and if we go fit with tolerance, user defined, then we get the whole basis, and then the shaft fit. So we could potentially go back to our chart and pick up those geometries to set for the H7 G6 combinations. All right, so I'm going to stay on this first pass with the none, and we'll go into positions. And if I want to turn on that, see if we get the flyout onto the fast layout, just to have it for reference. We'll go back into hidden lines visible so I don't tie these up. 2 points in this case will be plenty to align it. If I want to convert that geometry in and then make it for construction, go back and pick up the symmetry. Could have mirrored those again, and then place a nominal. Okay, so that doesn't look terrible. And make sure that we accept. Oh, I thought I hit the right mouse button so that it was accepting it. All right, so that comes up and stops. And then kind of looking through the part. So we would want this to be like up to maybe a plus 0.1 or 4 thousandths larger, and then the through hole smaller. And we can control those with the positional tolerance, but we have to think in terms of those stack ups. So if I go S key, and then this is going to be a blind in condition, so we'll have to work with those. So still a dowel instead of up to next. Let's see, we were going through 15 millimeters and the 12 millimeters. So 15 millimeters ought to be pretty good for the depth. And turn off the auto select so that we can tell it we want it just on that side. Now, I really shouldn't worry about coming back this way, but I think it's probably better to select it than to have it do something strange. We'll pick up the hole center and the hole center. So one of the advantages of the multi-body is I didn't have to build this over from scratch. We can tie these geometries together so that if I find that there's a problem, I can move them. And these are going to be far enough apart that as far as a pivot and with that lip, I'm gonna have a pretty stable structure. So this being another machine operation, I may do away with the lip and come back to just the pins. So you know, there's always options to this process. So when we get to the drawing, we'll look at making this a transitional fit. It can be a little bit of a press or just a light slip, and then we'll have a little bit more movement available in the pieces. I'm not looking at this that it has to be so rigid and so structured. The 4 M6s are going to provide that compression and the structure through the body. All right, so we'll go back to solid. We picked a 16 millimeter bushing. So the question would then be, do I want a flange bushing? Do I think that let's go take a look at the assembly. See, it will jump in. Nope. Not sure why it does that, picking from the taskbar, but we'll go ahead and rebuild the assembly, see if there's any issues. So the default locations, all right, we got all of those. And no errors on the mates, so it didn't do anything really crazy strange on those guys. So as far as the flange bushing, if this is going to potentially rub, I would leave this piece as steel. And then let's see if we measure. That we have 3 millimeters of distance. Well, I don't know that the flange is going to be that big. We may have to adjust for it, but since we have this room and material over here, then it would just be analyzing the connection here. So that being the case, let's jump back over and go to the flanged, and we'll just see how big those are. So the oil embedded, basically a centered bronze bushing, so it has some porosity to accept the oil. And we're looking for the 10 millimeter shaft. So for housing ID, and then we're at 16 millimeters, that should be overall. A length. So let's see what that looks like. 490 pounds of load at 120 RPM. So we get much above 120 RPM, we're going to have to look at a needle bearing or a ball bearing, maybe even one of the composite Freyline or PTFE lined bearings. So again, way more choices than we really want to make. So we've got the 16.03 plus O2 minus nothing, and then a plus 2. So 16 millimeters overall. That also means that we could potentially make that a little bit smaller, and amazingly enough, a 3 millimeter on the flange. So if that was going to provide a wear surface or a rub surface, then that would potentially provide us with that geometry. So one of the things I haven't tried yet with the McMaster site, I know Mitsumo, I believe it's called, is has an app to download directly in. So maybe we'll preview that. But what that means is that our 16 millimeters, other than this now being 13 millimeters, when we come back to the flange, if we can get back to the flange, there we go. Get into that measurement. Still not. So 18 millimeters overall. That's a lot if we're going to future discussion how we're going to carry this this motor and adjust the shafts. So the advantage here would be that having this extra material, extra mass, also gives me some possibilities to mount through if we need the coupling. Being able to make that that connection back to the shaft and having material here to connect to. So decision time is it going to be worthwhile? With an 18 millimeter width, we would start off with say 3/4 inch material, and it's going to end up about what would that be, about 810, so in inches. And again, just have to make those choices as we go. So if I wanted to switch these out to a flange bearing, I could do that relatively easy. All right, so I think let's go ahead and clean this up. We'll hide the sketch. Probably the last thing that I would do is I'm okay with the chamfers or the radius. Let's go with a fillet, and we'll put like a 6 millimeter fillet. So at some point I want to go back through after we've been through design review and have kind of the approvals to move ahead with these modifications as a re-engineered or reverse engineered assembly goes, that these are going to work, and the other materials are going to provide the same level that we can go with our our life cycle and material. So our next step will be to look at doing some manufacturing.